Hello everyone, welcome back to my channel Easy and Inspire. In today's session we are discussing about T flip-flop. T flip-flop is nothing but toggle flip-flop. Listen carefully. So in JK flip-flop we have seen, see here, in JK flip-flop we have seen only one important point, that is nothing but when J is equal to 1, K is equal to 1 and clock is applied to this one. See here, when J equal to 1, K equal to 1 and clock is applied, then the circuit goes to toggle condition. So this toggle condition, so this one is different from other like SR flip-flop and D flip-flop. SR flip-flop is having one condition, invalid condition. In D flip-flop we having only 0 1 condition and 1 0 condition, just two conditions. And in JK flip-flop, if J equal to 1, K equal to 1 and clock is applied, then toggle condition is occurred and it is overcome the problem of invalid condition in SR flip-flop. So for this toggle condition, we are developing another flip-flop. So to avoid the occurrence of intermediate states, so no intermediate states and just only one, that is nothing but toggle. So only one state, toggle state. If you want this, so just we will go for T flip-flop. No need to go for JK. So the main point here is this toggle flip-flop or T flip-flop is designed by JK flip-flop, just by modifying JK flip-flop. And the only important point here is it is designed to get the toggle condition, only toggle condition. So see here, T flip-flop is also known as toggle flip-flop or toggle switch. So we can design T flip-flop by making simple modifications to JK. So this is my JK flip-flop, we know. For this JK flip-flop, I am taking only one input. See here, this one input is directly going here and going here, not inverted. But in D flip-flop, listen, in D flip-flop, D is directly going to S and inverted D is going to R. But here both are same because one condition is toggle conditions. So to get these two same, just I am giving directly, no inverter here. So toggle condition, to get the toggle condition, JK flip-flop is given only one input, that is nothing but toggle input and a clock pulse. This is one way of representing toggle condition or toggle flip-flop using block diagram. This is another way of representing directly toggle input, clock, Q bar. So this is toggle flip-flop block diagram. Next we will see construction. So if you observe, this is JK flip-flop. For JK flip-flop, I am taking a single. So this is J, this is K, and one input is directly going to J and K. If you give, it is 0. J becomes 0, K becomes 0. J0, K0 means nothing but no change condition, we know already. If it is 1, J is 1, K is 1. J1, K1 means toggle condition. Just to get this condition, we are designing toggle flip-flop. So this is the circuit diagram. I'll explain the operation and working here. So we know already for JK flip-flop, if J equal to 0, K equal to 0, output is no change condition. Q is same, Q bar is same. So when T is equal to 0, J becomes 0, K becomes 0. The outputs are previous outputs, same as previous. So 0 1 condition is not valid here. 1 0 condition is not valid because if it is 0, both are 0. If it is 1, both are 1s. Only two conditions, either 0 or 1. So if both are 1, then so consider previous outputs are 0 and 1. So 1 1 are given. So it is toggle like 1 and 0. This is our output. So when clock is applied and toggle is 0, then Q is nothing but no change condition. So if t is equal to 1, if t is equal to 1, j becomes 1, k becomes 1, and clock is also applied. So it is toggle. So if it is previously 0, then becomes 1. If it is 1, it becomes 0. So main point here is toggle condition. And this is the truth table of T flip-flop. And we know that toggle flip-flop is having only two conditions. If T is equal to 0, if T is equal to 1. So main point is T equal to 1. So when T is equal to 0, output is not changed, nothing but same as previous. So Q of T, Q of T, Q bar, Q bar. So no change. So this is not the required. This is the important and required. When T is equal to 1. So sometimes output becomes 0, sometimes output becomes 1. Output becomes 0 if the previous output is 1. It is toggled and it goes to 0. If it is 0, it is toggled and it becomes 1. Listen. So this is output. So nothing but toggling output. So this is Q of T. Q bar becomes 0. So 1, 1, 0. This is truth table. And you will see the characteristic table. So this is the characteristic table. So only two conditions we are considering here in characteristic table. When T is 0, when T is 1. T is 0 means that state is nothing but no change state. So T is 1 means that is nothing but toggle state. Listen, this is very important. Toggle state. So study the matter carefully. So matter is nothing but when T is 0, whatever the present state may be, the next state is also same. When present state is 1, the next state is also 1 because that is no change. Present state, next state, both are same. But when T is 1, so it is toggled. 0 is toggled to 1, 1 is toggled to 0 because this is present state, this is next state. So T plus 1. So 0 is changed to 1, 1 is changed to 0. This is toggle condition. And only these two are very, very important. Just remember. And next we will see additional information. This is nothing but we can design toggle flip-flop using D flip-flop. This is the block diagram. You can design toggle flip-flop, D flip-flop using D. Same using SR. So in this session, I have explained all these using JK. So you can design using D and SR flip-flop also. Just I am giving this information. You can practice them. Next, applications of flip-flops. I'll explain in next class. Very, very important points. And thank you.